All right, let's just jump right in. In today's world of software, speed is absolutely everything. But as development teams are pushing to go faster and faster, there's this massive question hanging over everyone's head. How do we build cool stuff quickly without, breaking it? Or even worse, leaving the front door wide open for attackers? So today, we are going to break down the actual steps to building a solid DevSecOps practice and really transform security from being a roadblock into a superhighway for safe, fast innovation. To really get a sense of the scale we're talking about, just look at this number, 50 million. That is how many changes Amazon pushed out to production in 1 year. If you do the math, that works out to more than one change going live every single second. This isn't just moving fast. This is a totally different way of thinking about software. And that, right there, brings us to the heart of the problem. When the pace is just this relentless, how can the old way of doing security, with all the manual reviews and super long testing cycles, how can it possibly keep up? How do you secure a target that is literally moving and changing every second? That's the puzzle we're going to solve today. So here's how we're going to do it. First, we'll talk about this velocity dilemma. Then we'll dive into the new mindset you need, something called shifting left. After that, we are going to walk step by step through the entire automated pipeline, from the second a developer writes a line of code all the way to production. And finally, we'll get into why all the fancy tools in the world mean nothing without the right culture. Okay, first things first, the velocity dilemma. This is really the core conflict, right? DevOps is all about speed, about getting things done efficiently and just crushing delays. But traditional security, historically, it's been about playing it safe, putting up checkpoints and control gates, which, let's be honest, almost always adds delays. And in this new world, those two philosophies just totally clash. And this problem goes way beyond just speed. It's got a lot of layers. Agile and DevOps mean there's not really a big, formal design plan anymore, so security can't just review a document. Then you've got the cloud, which adds all this complexity with who's responsible for what. You've got microservices breaking apps into hundreds of tiny little pieces, which creates this massive surface area for attackers. And then there are containers, great for developers, but they can lead to this sprawl of software with all sorts of unknown vulnerabilities hiding inside. So what's the solution? Well, it really starts with a complete change in mindset. We have to shift security left. What does that mean? It means we stop thinking of security as this final step at the very end of the process. Instead, we pull it all the way to the beginning and weave it through everything we do. The goal here is to stop being a blocker and start being an enabler that helps developers go fast but do it safely. And you can really see the difference in this visual. Up top, that's the old waterfall way. See how security testing is way over on the right just before production? Finding a problem there is incredibly expensive and causes huge delays. But down below, that's the DevOps model. It's a continuous loop, and you can see security is just woven into every single part of it, from coding all the way to deployment and back again. So let's put a real definition on it. Shifting left basically means security is no longer just an afterthought. It's not the final exam before you graduate to production. It becomes a continuous, automated part of how we build software. It's all about finding and fixing potential problems when they're cheapest and easiest to fix, which is right when the code is actually being written. Now, the first big principle to make this whole thing work is building systems that are secure by default. This is huge. It means creating tools and frameworks where the easy path is also the secure path. So, for example, you build a database library that automatically handles sanitizing inputs to prevent things like SQL injection. That way, the developer gets all that security for free without even really thinking about it. And the second principle? Make security self-service. Think about it. Developers live in this automated on-demand world. Security has to fit right into that. So this means giving them tools that plug directly into their coding environment. Tools they can run themselves and get instant, clear feedback from. No more filing a ticket with the security team and waiting 3 days for an answer. That just doesn't fly anymore. I love this quote from the team at Netflix. It just perfectly captures the whole philosophy. A gate, right? It stops you. It's a hard no. But a guardrail doesn't stop you from driving forward. It just keeps you on the road and makes sure you don't fly off a cliff. And that is the goal of modern security. Provide that guidance, that automated protection that actually enables speed instead of killing it. Okay, so we've got the why and the philosophy down. Now let's get into the how-to. Let's see how this actually looks in a real pipeline. We're going to start at the very, very beginning. The stuff a developer does on their machine before they even commit their code, and the automated checks that kick off right after. This diagram here is basically our map for the whole process, all the way from a developer making a change to that change going live. And the key thing to see is that at every single one of these stages, we can inject automated security checks. So let's zoom in on those first two boxes, the pre-commit and the continuous integration stage. The first thing to get is that security really starts on the developer's laptop. I mean, before they even commit their code, they can run super fast analysis tools right inside their editor. We call this static analysis, or SAST, and it basically reads the source code to find bugs. Even the peer code review process is a form of security check. Then, the moment they commit, the continuous integration server, the CI server, automatically wakes up and runs its own checks, like software component analysis or SCA. That's a huge one. It scans all the third-party libraries you're using to see if they have any known vulnerabilities. All right, let's follow the code to the next stage in our pipeline. So once a build passes those initial CI checks, it gets automatically deployed to a testing environment. And this is where we can run a much more thorough set of automated tests to make sure the new code works right and, hasn't broken anything else. And in this stage, we bring out the bigger guns. We can run automated dynamic scans, or DAST, which basically act like a friendly hacker, probing the running application from the outside looking for weak spots. We can even run our own automated attack scripts to actively try and break our own system. Now, some of the more intense stuff, like really deep code scans or a full manual penetration test, we often run those out of band so they don't slow down the main pipeline. But the findings still get fed right back to the developers. But here's the thing a lot of people miss. Security does not stop when the code gets deployed. No way. In some ways, that's when it's just getting started. A really strong DevSecOps practice has continuous security monitoring and defense built right into the live production environment. So once we're live in production, we've got a whole different set of tools and practices. We're talking constant monitoring, runtime defense tools that can actually block attacks as they happen, and automated compliance checkers, like Netflix's Security Monkey, that are always scanning your cloud environment for mistakes. And it also includes being proactive, hiring ethical hackers to do red teaming or running bug bounty programs to find the vulnerabilities you might have missed. Okay, we have covered a ton of tools and pipeline stages, but I have to be honest, none of it, not one bit of it, works without the most critical piece of the puzzle, culture. You can buy the best, most expensive scanners in the world, but if your culture treats security as somebody else's problem, you are going to fail. The real goal is to build a culture where everyone shares ownership. And Etsy is just a perfect example of this. Their whole security culture is built on a couple of simple ideas. First, trust your engineers to do the right thing, but use automation to verify. And second, and this is so important, security cannot be a blocker. They literally believe that the word no is a finite resource, something you only use when it's an absolute emergency. Security's job is to help teams ship safely, not to stop them from shipping. This right here really gets to the core of that cultural shift. The old way? Security is a blocker, working from its own separate silo. In a DevSecOps culture, security is an enabler, embedded right inside the development teams. Instead of being this final gate that everybody is scared of, security becomes a shared responsibility that everyone feels a part of. So let's wrap this up with the most important takeaways. First, shift left. Embed security as early as you can and do it often. Second, automate everything. Seriously, whatever you can automate, do it. Make security a totally seamless part of your pipeline. Third, empower your developers. Give them self-service tools and build that culture of shared ownership. And finally, always remember that mantra. Move from gates that block to guardrails that guide. And that really brings us to our final thought. Look, building a full DevSecOps practice is a journey. It's not something you just flip a switch on overnight. So the question I want to leave you with is this. Looking at your own process, your own pipeline, what's the very first, simplest guardrail you can build? Maybe it's just a simple check for secret keys in your code or an automated scanner for vulnerable libraries. The whole journey starts with that one small step.